Hello everyone, good afternoon. Okay, so as I posted on Google Classroom, there will be 50% attendance requirement, okay, now onwards. So please maintain your attendance, it's very important. And this is all for your own good, okay. So I encourage you to ask questions and also solve, like go through all the lecture videos, do the tutorial problems, and any doubt, please ask questions. Okay. Okay. So any questions so far? Any doubt you have? Otherwise, we'll move to solving the tutorial problem. Yeah. Okay. So let's solve the tutorial problem. Yeah. Okay. So we will start with problem number. Last live session we solved problems from chapter 2. Now we will solve from chapter 3. So chapter 3. Okay, so chapter 3 we have questions 5, 6, 7, 11, 12, 13. Okay, so these are the tutorial problems. So we will solve it. Okay, so problem number B35. Okay, and it says that there is an inverted problem. Yeah, so like inverted pendulum problem. So you have something like this. You have a cart here, then it can move in horizontal direction. Then you have force. U is force. Okay, so this is force. Remember. Okay, so U is given as force, and then there is a bar here. So something like this. Yeah. So there is a bar which is given like this, and this is angle theta. This bar total mass is m. Yeah, and this is the center of gravity G, which is L from here, and means midway. You have the center of gravity for that. Big mass M, a small mass for this one. Okay, and displacement in this direction is x, and rotational direction, the displacement is theta. So for that, what you have to do, find out the equation of motion. So if in form of differential equation, you have to derive the mathematical model and transfer function accordingly, you have to find out. Yeah. Okay, so then how to solve it? Okay, so for that, always start with the free body diagram. So let's see. So we have big mass here, M. Yeah, so we have like this one here, and then if U, which is a force, is given like this one, then there will be reaction forces, right? So let's say reaction force here is R, Y, okay, and then this is Rx, and on the bar, we will have Ry, which is upward, then Rx, which is because of the pin joint, right? So we have the pin joint here. So here, this is a pin joint. So we have this, and then there will be a because of the gravity, which will mg. Yeah, and now we have to. So equation is from here. So this is theta, like this one. So looking at one, you have, from here we can find out what do we have. We have in vertical direction, total force in x direction equal to m times g, right? Sorry, not m times and x double dot, right? So x, this way, this is x, that's why. Yeah, so that means what? Total force is how much? Total force is, you see here, u minus rx. Right? So you have u, which is a force, minus rx equal to capital M x double dot. Okay, vertical we don't need, because vertical there will be a vertical force is Rw. Yeah, yes, Shanu. Yes, Shanu, you raised your hand. Okay, I guess by mistake, huh?
Yes, sir, by mistake it was.
Yeah. Okay. Okay, so u minus rx you get from there. Okay, now this is done. Vertical force we are not bothered, because this will be, this rx ry will be equal to this, this reaction force will be equal to this ry plus this mg, right? So vertically, which is, so this will vary accordingly, but we will not use it. It will not be useful, So anyway, so now for this, what do we have? We have this equation now. Rx here, we have same Rx here. So again, same equation, the sum of forces in x direction has to be, now it will be mg, sorry, m, yeah, and then what? Okay, so now we have to find out with respect to what? Okay, sum the forces all with respect to, we are looking at this point, yeah? Or we have to see how the center of gravity is moving. So how do you know? So m is fine, but let's say we call it a capital X double dot. Okay, where capital X is the x component of the this point, and what is that point? So we can find out what that point is. So from here to, if you see, this will be equal to, so this point is x. So since this point are same, right? So if this moves by x, this will also move by x, and plus this one, and this is how much? This one will be x plus, and then we have here to here it's L, and this is theta. So this will be L cos theta, this will L sin theta, right? So plus x L sin theta, yeah? So which is equal to big X. So we can write accordingly, will be equal to total forces Fx here. So we will have Rx, yeah. So Rx is positive x direction, and what do we have? No other things, just this one, no other things we have. So Rx will be equal to m times x double dot plus if x is either we use this one, and we can assume theta is very zero, very close to zero. So we can also write this equal to x plus L theta, yeah. Hence you get here x dot plus L theta double dot. So you get Rx equal to this, yeah. Okay, and this is then another equation, and that equation will be summation of forces in y direction has to be equal to small y double dot, and where ry minus mg, right, as equal to m, and what is y value? So y value we can get from here. This is, so this is the y value, right? This is the y value. Yeah. Okay. And y will be equal to L cos theta. So L cos theta, right? When theta is very small, then that value will be 0. Otherwise, there will be some value. Yeah. So what do we get in that case? So we are assuming theta very small. Theta very small. So in that case, you get y equal to simply equal to L1. Yeah. Okay. So here you get L theta. Sorry, this will be L cos theta. So this is equal to L. This will be double dot. So it will be equal to 0. Yeah. So you have this equation, and from you can what you can do is you can combine this and this. See, you have Rx here, we have Rx here. We combine them together, and we can find out the equation. Right? So we will have one equation. Yeah. And here one of them will be like both are related. There will be two equations. Like from here you get Ry equal to mg. So here if we just find out what Ry is, but this and this we can combine together. We can find out the value of. So combine them together. Okay, and what do you get from this and this? We get this u equal to m x double dot plus L theta double dot, right? Okay, plus mx double dot. So this is what you get. Yeah. So this is the equation you get. And now, in order to find out like what is the main motive here to find out transfer function, right? So transfer function. So how the transfer function in this case will be output over input. So what is the output? So output here is the theta. Theta is the one that we want to control. And however, there are two outputs here. So accordingly, there will be xs over. So let's see here. So looking at it, we have u equal to, so u equal to, we can combine together. So a small m, a big M plus big M, x double dot, plus you have L theta double dot, right? L theta double dot. Right? Okay, and now what we'll do, we'll take Laplace transform of that. So you get u s, right? And is equal to, then you have m plus m, and then you have s square xs plus ml s square and theta s. Yeah. So this you have, and again, if you divide it by us, so you get m plus m s square, and then you get x, xs plus us. Then no, this will not be okay. So yeah, plus you have ml s square, yeah, multiplied by theta s over us. Okay, it will be equal to 1. Yeah. So since there are two outputs, and depending on the one value, the other value will depend on that. So other than that, so just a minute. Okay, so it also asks the state space equation. So state space, as I told in the lecture video, that this is not in your syllabus. So the state space we will not cover here. Okay, but this gives you the relationship between the input and output, where input is this, and you have the x output, and you have the theta output, both of them. Yeah. Any question, guys? Okay. Okay. Now let's see. Look at the B36. B36, and here you have this kind of problem. You have M1, okay, this is K3, this is K2, yeah. Okay, now this is the what you have studied earlier. So here there is a force which is U1, and then displacement x1. So nomenclature has changed, and then x2, right, and K2 and B2, like this one. This is multi-degree of freedom system, and accordingly you can find out. Basically, there will be two equations, and you solve it, right? So there will be system of equation that you have to solve. There will be two things. There will be two outputs basically for the same input. This is the same as the previous case. Yeah. So you have two outputs basically because of and only one input. Yeah. Because 2 degree of freedom system. So here also you have this kind of things, and you have to solve it to find out the values. Yeah. Okay. Now, if you see the first mass, so M1, for example, so you have you do same kind of analysis as earlier, like as you have done in the vibration section. Yeah, so if it moves by x1, then what happens? There will be a force which will be backward. This is k1, so you get a k x1, and there will be a force because of the damper, which will be equal to, this is b1, so you get b1 x1 double dot. Yeah, and there will be force because of this also, because of this one. Yeah, so let us say x2 is very small, x1 is big, so this will be compressed. Because of compression, it will go this way. So there will be force k3 and x1 minus x2. So you this is the force, and then the equation will be like this. Will be m1 x1 double dot, right, plus k, this is k1. Okay, so k1 x1 plus k3 x1 minus x2 plus b1 x1 dot, right, and that is equal to there is a force u also given. This is a u. So yeah, this is the u, not u1 but u. So that is equal to u. So this is U, right? And then what will you do? If you take the Laplace transform of that, then you can find out M1 S square X1S plus K1 X1S plus K3 X1S minus K3 X2S plus B1S X1S is equal to US, right? And you have this one equation. Similarly, you can find out from second equation, and then you can solve them to find out X1 and X2, right? Same kind of thing you can do here. So here, second equation will be like this. We have M2 and you have K2, X2, then you have B2, X2 that, this is X2, and here you get in this direction K3 and X2 minus X1. And equation will be equal to M2, right? Sorry. Okay, guys, here we have, yeah, so in similar fashion, we can have our equation will be M2 X2 double dot plus K2 X2 plus K3 X2 minus X1 plus B2 X2 dot is equal to 0. And take the Laplace transform, and then you get M2 S square X2S plus K2 X2S plus K3 X2S minus K3 X1S, yeah, plus B2S X2S is equal to 0. So this is the equation number 2, right? And this one is equation number 1. So you can solve this, right? So this will be in a matrix, right? If you like from 1 and 2, simply I write here solve 1 and 2 to get what? To get X1S over US and X2S over US, right? So this is how you can find out. Any question, guys? Okay, now 7. So B37. So you have a circuit here given R1 and R2. Then we have inductor here. Any question? Okay, so we have L here and EI, I2, C, and E0. Yeah. Okay. Now, this okay. Now here we have to actually find out actual current which are flowing here, right? So you can also write in terms of the impedance, right? So this is R1 impedance here, and then you have R2 impedance here, yeah, and then here you have L times S, which is the impedance, and here you have 1 over CS, which is the impedance here. So we have like this, and then we have to find out, right? We are taking the complex, so we are already taking the Laplace transform for all the resistance, capacitors, and inductors. And we have this, which is I1S, and we have EI, EIS, output is EOS, and here we have I2, so this is I2, like this. Yeah. Okay. Now, next thing will be to actually we have I1 here and I1 here, right? So okay, so we have I1, and I1. This is all I1. Yeah. Okay, and then from here to here, this one, we have. Actually, we can do either way. So we can assume that I1 goes like this one. I1 is split into two parts. So this becomes I2. This becomes I2, and this one is I1 minus I2. We can do like that. So I1 is coming here, then I2 goes this way, and I1 minus I2 is this one, then this also becomes I1. So we can do like that. Okay, now, we can write the equation, and the equation is R1 times I1, I1S plus LS. Yeah, LS, then I1 minus I2, right, is equal to EIS. This is first equation, first loop. This is first loop. This multiplied by I1, this multiplied by I1 minus I2 should be equal to EI. This one will be I2 multiplied by this, I2 multiplied by this, and this will be the LS multiplied by minus I2, because this is this direction, and should be equal to 0. So we can write the second equation, which will be equal to R 2I2S, then I over CS, then I2S, and then minus LS multiplied by I1 minus I2, and has to be equal to 0. So we have two equations, and then we have to solve it to find out the answer. Yeah, so solving, we can find out E0 over ES. So how, what do we have? We have I1 and I2. We have I1 and I2. So we can find out I1 and I2 and put those values here, and we can find out the okay. So what do we have to find out? We have to find out I1 and I2. So first we have to do solve to find I1 and I2, and then E0 will be equal to I2 multiplied by 1 over CS. Yeah, and which will be in form of I1 only, right? So I2 will be as a function of EI automatically, and then find E0 over EI. So you can find out easily after that. So main thing is writing these loop equations, and from there is you solving. Similarly for 3/8 also we can do. Yeah. So for 3/8 we have, instead of like 3/8, B3/8, these are just resistance and capacitors. So this is R1, C1, and then you have R2, and then C2, like this. Yeah, so similarly you can do. And here again, you don't assume that don't assume this output will be here, output over input, and then output over input, just you multiply together, we'll get it. It's not like that. You have to actually solve the equation as we did. Yeah, so this is leaving on you, B38. Okay, any questions so far, guys? So anyway, 38 was not in the tutorial, but still I told you. 11, 12, 13 now. Okay, so 11, 12, 13. Okay, now this is about operational amplifier, and here the equation which looks like this. So 3B 311 we are talking about, and this looks like this. So we have a capacitor here C, and then op amp here, so plus minus, this is A, this is B, R2, R3, E naught, okay, so this is A is writing, this B here is written, this is then between A and B there is another resistance which is coming here, and there is a earthing here, so this is EI, this is E out. Okay, so how to solve it? Okay, so there are shortcuts also. If you want to solve this kind of question, op-amp questions are very easy, in fact. So first off, you see that this is 0, right? So this is grounded, so 0, and this is E naught, right? If this is E naught, then what will be the value here? So here it will be simply, if you see from here to here, this will be simply R3 divided by R2 plus R3, right? So this voltage will be divided into two parts. One will be this voltage, another will be this, and this will be simply R3 divided by, so we can write it. So here you have R3 divided by R2 plus R3 and E naught. Yeah, so this is the value here. Okay, now if the voltage here is this much, same voltage here, and for op amp, this value and this value will be the same. Yeah, this is op amp will make sure that the voltage here and here both are the same. Yeah, this is how it works. So you can just straight away we can put this value here, and simply this is R3 E naught divided by R2 plus R3. Just you do that, and then you will see that you can work out now. So once you know that, then there is very easy to work with. So finally, what do you have to find out? E naught over EI. So now if E naught is here is that like this is what is value of EI? That's the same, right? So now we have to work backward, and how you can find out? You know that there is no current going inside. Yeah, current is 0. So that means whatever current is going like this only. There is no other thing. Yeah. So let's assume current is I here, which goes I here. Right? This is how it is. Yeah. So if that is the case, then we can find out I will be equal to, okay, I will be equal to impedance you have, and total value is EI. So what we will do is we will take the Laplace transform already. So EIS divided by 1 over CS plus plus, and this is R1. Okay, this is R1 plus R1. So this is I. And so if you want to find out this value, it will be simply R3 times I will be equal to this, right? So what you get? R3 times I. Sorry, R1 times I. So this is R1. So R1 times I, right, which is equal to EI times this EI times R1 divided by 1 over CS plus R1 is equal to R3 E naught. E naught, I will take the Laplace transform. So capital E naught R3 over R2 plus R3. So finally we have this equation. EI R1 over this equal to R3 E naught by C. So from this equation, we can straight away we can find out output over input. Yeah, so output over input will be E naught divided by EI will be equal to simply these things will go up, right? This will go down. That's it. Very simple. Any question, guys, so far? Okay. Okay, so now let's move to the next one. Okay, so we have B12, B312. Yeah. And here, what do you have? Using the impedance approach, just a minute. We have 12. Yeah. Yeah. So what is the equation? The circuit here. So we have op-amp. So we start with this. Have like this, and then minus. We have plus here, like this. Then we have R2. It goes like that. Okay. Then we have capacitor here. Then R1. Same value R1 is again there. So this is R1 again. This is C, R2, and then goes like this. So this is EI. Okay, so we will write in after Laplace transform, so we can write E naught here, and this case we'll write EI, both S and S. Yeah. Okay. Now we have to find out what is we have to find out transfer function, which is means E naught over EI S, and S is equal to what? So this transfer function we have to find out. Okay. Again, analysis is very easy. Yeah. So looks like electronics and all. So, but don't be afraid. This is a very simple trick, and trick I told you is that op-amp will make sure that the V here and here will be the same. Yeah. So potential here and here will be the same, and this is how it works. Okay. Now remember, if this and this value is same, you have to somehow you have to reach that condition, and for that how we are going to do. So we do like this. Now if see here, if this one is earth, yeah, so we can write 0 here, so 0 here, and then this value becomes EI, and this value becomes E naught, right? So that means E naught is here, yeah, and here this is EI, and let us say that current flows from here, yeah, so it goes, current will come from here and go this way. As I mentioned earlier, there will be no current here, yeah, there is no current here. So this will, the op-amp will maintain two things. One, here and here voltage will be the same and there is no current getting inside, means current will be very small, yeah. That means current will come and go like this, simply like this, or here also the current will go like simply like this, yeah. So there will be, let us say, call it I1, right? So same I1 will flow from here to here, and if you say I2, same I2 will flow here to here. So I2 goes like this and I1 goes like this. There is no current flowing through this, yeah. So this is what the condition is, and that we have to analyze. And analysis, how will you do? Okay, so we do analysis and we'll equate this voltage and this voltage, yeah, and then we are done. So this voltage, let's call it point A and B. Yeah, so let's say this call point A. This is called point B. Yeah. Okay. So point A. So VA. So VA will be equal to, okay, since this is flowing like this, right? So VA will be equal to a small one, so E naught plus a current, which is I2, yeah, current I2 multiplied by R1. So this V naught is nothing but E naught multiplied by R1 multiplied by I1. Yeah, so since this is going like this one, this has higher potentials over this one, we have assumed, so it will go like this one, where I2 is, this will be I1. This will be I1. Okay, I1 only. Where I1 is nothing but equal to E naught, EI minus E naught divided by R1 plus R1. So simply this will be equal to E naught plus EI minus E naught over 2R1. This is I, right? Total resistance is R1 plus R1, 2R1. So 2R1, voltage difference is E1 minus E naught. So E1 minus E naught, this I multiplied by R1. So here you go R1. Or simply this will be equal to E naught plus, and here R1 cancels out. So this becomes EI by 2 minus E naught over 2, or simply EI plus E naught over 2. Okay, and it makes sense, right? So here you are EI, this is E naught, and this is just in middle. So it should be average of this and this, because they are connected with just R1 and R1 from both the sides. It should be just, the value should be mean of this and this, and that's what we get here. Yeah. Okay. So that means once we have this one, the next thing will be to find out the VB, right? So let's say VB. Okay, so VB, and what is the value of VB? The B point is here. So we have 0 here, and we have EI here, and current is flowing like this one. So accordingly, we have to find out VB will be nothing but equal to I2 multiplied by R2. Right? So VB equal to I2 multiplied by R2, and I2 and R2, where I2 equal to the E1 minus 0. So basically E1 divided by the the total impedance, right? So basically where I2 will be equal to EI divided by 1 over CS. Yeah, because this is C, so 1 over CS, and then plus R2 plus R2 plus R2. Yeah, so this is I2 multiplied by R2. Yeah, so this is VB, but remember that VA equal to VB, that we have to set equal to, and hence VA is equal to E1 plus E0 over 2. So which is, that really means this value means EI R2 over 1 over CS plus R2 equal to, yeah, this will be equal to V0 plus VI divided by 2. Yeah. Sorry, not V but E. So EI plus E0 divided by 2. Okay, so we got the equations, and from that now we can simplify and we can find out the solution, right? So how to simplify? So or we can write, and then we have we multiplied by CS up and down of this CS here, so we get EI R2 CS divided by 1 plus R2 CS, yeah, and transfer 2 to here, so 2 here, 2 is equal to EI plus E0, yeah, and then we move it here, so we have this minus this, so finally it's just a matter of simplification now. So 2 R2CS 2 R2CS 2 R2CS, right, divided by 1 plus R2CS, 1 plus R2CS CS minus 1, and you have EI is equal to E0, right? E0, or we have here can find out, and we get minus R2 CS minus 1 divided by R2 CS plus 1, EI equal to E0, or simply E0 over EI is equal to R2 CS minus 1 divided by R2 CS plus 1. Okay. So this is the transfer function. Okay. Okay, so this is how you work on this, and op-amp is very important because this is the one that is used for controller, you know. So any kind of controller you are thinking about, and finally that has to translated into some kind of electrical circuits. Yeah, so and any kind of transfer function you are looking for, this will make. Yeah, so that's why it's important. But this is how you go. Okay. Okay, so this last question, which is number 13. So please do yourself. Okay, any problem you face, you can discuss with me. So B313, which is based on the motor control. So that we have discussed already. Yeah, so one of the later videos we had the motor control system we discussed. So this is based on that only. So we have already done in the class. Yeah, any question, guys? Any question? Okay. Okay, guys, if there is no question, then just one announcement that next week on Wednesday, I will be traveling. Okay, so I will reschedule. So I will send you email. So when that will be. So maybe we can do on Tuesday probably. Yeah, sometime. Okay, the live session I'm talking about. Yeah, so I will let you know when. Okay. And then we also have to work on homework. So hopefully I will have homework posted by this weekend. Okay, so okay, guys. Any questions? Okay, if there is no question, okay, see you next week. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.